Solving with the quadratic formula, I know you've done this one before. I know you've been exposed to the quadratic formula before. This is a formula that is a fail-safe for you that literally will work for any quadratic that you're wanting to solve no matter what. It's just kind of gnarly sometimes to reduce if you're not using a calculator or you're wanting a reduced radical form instead of a decimal answer. And that's what I'm going to want from you. So we're going to have to do all of this by hand. I've got an exact problem worked out for you already typed on your notes so you can kind of see how it works and where the details go. We're going to highlight this one if you want to follow along with me. So following the quadratic formula, I don't have to do any sort of prep work. I don't have to divide by 8 like I did for completing the square. I don't have to rearrange this formula. As long as it says equals 0, I'm good to go. We get the a term here in front of the x squared. It's in standard form. We get the b term in front of the regular x, and we get the c term, the constant, which is the number just straight up by itself, and we take those numbers and we plug it into the formula. That formula is x equal to negative b. Look at all of the parentheses I'm using. That's a negative parentheses, whatever the number is, b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So step 1 when I'm doing this is just to plug it all into the appropriate places in the formula, which yes, does mean you need to have that formula either memorized or as a reference for you to know this formula. Then we just start reducing this. So this is an arithmetic problem after this. We start underneath that square root, just trying to figure out what that number is. So in this problem, I did negative 4 times 8 times negative 1, and I got 32. Then I did 4 plus 32, I got 36. I got lucky because what is the square root of 36? That's going to be nice and pretty. This is when I'm going to have a much prettier answer than potentially having a reduced radical or an imaginary number. Well, then I have a negative b, which was negative 2, and I'm going to add 6 and then divide by 16, and I'm going to subtract 6 and I'm going to divide by 16, which means at this point it might be helpful to split it and say, all right, I'm doing negative 2 plus 6 and negative 2 minus 6. Negative 2 plus 6 is 4. 4/16 is a fourth. And negative 2 minus 6 is negative 8. Over 16 is negative a half. So I have two solutions, and they are negative 1/2 and positive 1/4. We've seen the quadratic formula before, yes? Yeah. A lot of times you'll be able, if it's asking for a rounded answer, just go straight in the calculator from plugging it all into the final answer. But if it wants what's called an exact answer, you're going to want to reduce it by hand so you don't lose those exact numbers. You're not rounding anything. So for example, one that does not have nice, pretty answers at the end, I'm already giving you a warning, is this guy. Okay, what is A here? 2. What is B? What is C? Great. We're going to plug it into the quadratic formula slowly so that we can follow along with me. The quadratic formula is x equal to negative b. Now notice I'm doing negative parentheses negative 6. Negative b. Plus or minus the square root of parentheses b, tons of parentheses, squared minus 4 times a times c. So I put the 2 and then I put the 1. All of that over 2, and again parentheses, times a. Let's just plug in. Once we got it all plugged in, we start to reduce slowly. Always wanting to start with the minus a minus, we can make that go away. 2 times 2, we can make that go away. That's easy. But we're wanting to focus mainly underneath that square root to start reducing the numbers there. Minus 6 is going to be positive 6, plus or minus the square root of negative 6 squared, which is 36, minus 4 times 2 times 1, which is 8. All over 2 times 2, which is 4. Continuing underneath that square root to try to make that a little bit simpler, we would have 6 plus or minus the square root of 28 over 4. Can I take the square root of 28 and it be perfect? No, it's not a perfect square. So that means I'm going to have to break the number 28 down into its prime factorization. A lot of us like to do this in that tree format. Yeah. How do you break down 28? 2 and 14. How do you break down 14? 2 and 7. Are there any pairs?
2.
And any leftovers? 7. So the 2 is going to pop out and the 7 is going to stay underneath. So I would end up with 6 plus or minus 2 square root of 7 over 4. If you notice, all of the coefficients or constants in this problem are divisible by 2. We can reduce all of those coefficients. Notice I'm saying coefficients and not radicans. You cannot touch the stuff underneath the square root. But if these 3 numbers are all divisible by the same number, you can reduce. What are they all divisible by? Let's take a 2 out of this whole fraction. This is going to be 3 plus or minus 1 times the square root of 7 over 2. Now that's 2 solutions, right? And that's great. So if this question asks for what's called an exact answer, this is what you're giving them for exact answers. Maybe split plus or minus, maybe split at the denominator, but an exact answer. We can also give a decimal approximation. So if you would please, did we grab calculators? Grab a calculator real fast. I put new numbers potentially for your class up on the wall. Grab a calculator and let's find a decimal approximation for this term. Did we have a chance to evaluate these? What is one of the 2 decimal approximations? I got 2.823 for one of them. Do we agree? And then for the other, because you have to do both plus and minus, I got 0.177. So that is both the exact answer and the decimal approximations. Depending on what I'm asking for, it will say exact answer, or it will say decimal approximation, or it will say both. Can I let you try one to see what happens? Yes. This last one is for you. Let's see if before we head to lunch, if we can get this entirely done. We have like 3 minutes to lunch. So we got 3 minutes. Let's math. We would have to separate this into the real part and the imaginary part. Meaning I would need to, in my calculator, and I'm going to write this down, then I'm going to erase it. I would need to do 1/3. And then I would need to do square root of 11 over 3 and then put an I next to it. I'd have to do those 2 parts separately, which means my decimal approximation here would be 0.333 repeated plus or minus 1.106 I. That would be the decimal approximation. You have the real part without the I, and you have the imaginary part with the I. Did I say that backwards? This was a negative 44. Square root of -1 is I. Yeah.
Okay, I get it.
Until next time it shows up.
I think I got it though.
Okay, cool. So honestly, I like the exact answers here because I don't have to round anything. But just make sure you read the instructions into whether you're asked for the exact or if you're asked for the decimal approximation when it comes to these problems. Any other major questions before we flip the page over? Okay, cool. On the back, this last little bit of 1.5 is talking about the discriminant. We've already actually used the discriminant. I've just not called it that. The discriminant is all of the stuff underneath the square root sign in the quadratic formula. It is the radicand. So that we are looking at b squared minus 4ac, all the stuff underneath the square root. And what's nice, yes, if you have b squared divided by b squared minus 4ac, and if you calculate that, you're welcome, and the number is bigger than 0, that tells us that we are going to have two real solutions to our quadratic. We should get two number answers. They may not be pretty, but we should get two real numbers. If our discriminant is equal to 0, that means we're going to have only one real solution, and it's a repeated root, a bounce. If our discriminant is less than 0, this is when we'd end up with an I in our equation because we'd have a negative under the square root. We're going to have two imaginary solutions. So the discriminant actually tells us a lot of information about our quadratic just to start. So we're going to compute the discriminant for each of these things and then use that discriminant to determine how many and what type of solutions that particular quadratic would have. So for this one, if we're just calculating b squared minus 4ac, I'm still finding b, a, and c. This would be b squared minus 4 times a times c. And I'm just going to calculate that without a square root, without the crazy quadratic equation surrounding it. We're just looking at the discriminant. Well, 4 squared is 16. 4 times 3 times negative 5 is, well, negative 4 times 3 times negative 5 is positive 60. Which means that my discriminant is 76. Now, the discriminant being the number 76 tells us what about this quadratic? Your options are two real solutions, one real solution, or two imaginary solutions. Two real. If that number is a number bigger than 0, which 76 is bigger than 0, that's going to tell us that we have two real solutions to this problem. We compute the discriminant for the middle example, b squared minus 4ac. I'm going to use a little less color coding here. B squared minus 4 times a times c. This would be 36 minus 4 times 9 times 1. Well, 4 times 9 times 1 is 36. So what's my discriminant? 0. And what does that tell me about this quadratic? That we have only one real solution, and it will be a repeated root. When we graph, there will be a bounce at that particular x-intercept. And last but not least, finding the discriminant for this last, we have negative 8 squared minus 4 times 3 times 7. Negative 8 squared is 64. 4 times 3 times 7, if you trust me, is 84. 64 minus 84 is negative 20. So my discriminant is negative 20. What does that tell us for this quadratic? Tells us that there are no real solutions here. Okay, thank you. No real solutions, or that we have two imaginary ones. Anytime you have a negative as your discriminant. So it's nice to kind of calculate this first, especially if you end up with the one real solution. You know you're not going to have to work necessarily as hard when you're using the quadratic formula. We do always want to start with reducing that part first. Gives us a good idea of what we can be looking for in the problem. Lingering questions, comments, or concerns about 1.5? So we should be able to finish the rest of that homework that you got last class. I know we didn't have all of the stuff out there yet. So I was going to say so close, but honestly, you can not even close to throwing that in the trash can. Yes, sir? Yes. But we are going to go ahead and move on to 1.6. Oop, I didn't turn this off.